So let's start off with talking a bit about this idea of factorising. Okay. Now, the first idea you always try with factorising quite often is the most forgotten idea, and that is simply looking for a common factor. If there's a common factor, pull it out. It can make factorising the overall term a lot easier. So always look for the common factor first. Then the number of terms that you have tells you which approach to have. So if you've got two terms, common factor, what else could it be? Well, maybe it's the difference of two squares. That ends up in two terms. There's something we'll look at a little bit later called the sum and difference of two cubes. So maybe that's something we're looking for. If it's got three terms, so a trinomial, is it a quadratic? Right? Remember what multiplies together to give the last number, add together to give the middle? They usually have three terms when we're trying to factorise those. Four terms. Grouping in pairs is usually an idea we try if there's four terms there. Well, common factor, this is going to be a tricky example. But always keep in mind, factorising is simply dividing by a common factor. Now, one of the mistakes people make with factorising is they take the factor out and then they go, oh, what's left in the parentheses? Well, you just divide by what it is you've taken out. That's what factorising is, dividing by the factors. Oh, as I say, very tricky question there. AX plus BX, what have they got in common? X. So we take the x out, and if we were unsure, we go, oh, well, AX divided by x, that's A, and BX divided by x, well, that's B, and tells us what's left in the parentheses. So that's the basic idea. 5x squared minus 10x, the reason I pull that one in there is, remember to look for all of the common factors. The mistakes that are made with this one is just to take out the x, or just to take out the 5. But of course you need to take out all the common factors, 5x. Four terms there. I put it in common factors because grouping in pairs really is common factors. Because you look at this and you say, oh, what's common? Oh, look, they've both got x. Oh, the other two don't. Damn. Oh, look, the two of them have got m. Oh, the others don't. Damn. And so on. It doesn't matter what you do, you can't find a common factor. So if you look at them in pairs, it makes life a lot easier because it changes it from four terms. You could now think of this as two terms. One of the terms is x outside of n minus n. Then the other one's negative y outside of n minus n. And they have the common factor of n minus n. So grouping in pairs really is just an example of taking out common factors in a lot of cases. Oh, and by the way, with grouping in pairs, you can pick any pair you like. And if it doesn't work, well, just try a different pair. The key with grouping in pairs is to try and get the same thing in both parentheses. So you then have that common factor you can pull out to complete the factorisation. Okay, difference of two squares. Well, it's just the reverse of what we saw before. Obviously, if we expand out a minus b, a plus b, we get a squared minus b squared. So if I want to factorise a squared minus b squared, I must then go back to a minus b, a plus b. So 16x squared minus 1. Obviously, the first one is 4x all squared, and 1 is 1 squared. So 4x minus 1, 4x plus 1. You look at this one and you go, well, hang on a sec, 3, 75, they're not perfect squares. Of course, there's nothing stopping me factorising it just because it's not a perfect square, because I could say 3 was the square root of 3 all squared. Mind you, that's not what I'm going to do, because the first thing you do is look for the common factor. And in fact, 3 does go into both. That now leaves me with the classic perfect square of y squared and 25. Always look for that common factor first. So y squared minus 25 will be y minus 5, y plus 5. Another grouping in pairs question, but this time it's not necessarily common factors. If I grab the first two, I've got a common factor of 5, but the second two terms, x squared minus y squared, I factorise by difference of two squares. So it becomes x minus y, x plus y. Now each of these two terms have the common factor of x minus y. So I take the x minus y. What am I left with? Remember, it's just division. 5 lots of x minus y divided by x minus y leaves me with the 5. And the x plus y, x minus y divided by the x minus y, I'm left with the x plus y. So there is 5 plus x plus y. Okay, let's have a look at trinomials. I know that if I expand x plus a, x plus b, I end up with this wonderful expression, x squared plus a plus bx plus ab. This is why we say, when we're trying to solve them, what multiplies together to give the last number, so what's ab, and what adds together to give the coefficient of x, or the middle number, so what's a plus b. Because once I know what a and b are, I can go back to the factorisation, x plus a, x plus b. Okay, multiplies to give 18, adds together to give 9, the sorts of things we're looking for. It's a positive number, so I know the numbers I'm looking for are either two positive or two negatives. But they add to give a positive, so therefore logically I'm looking for two positive numbers. Fairly simple one, that's 6 threes are 18, add 6 and 3, we get 9. So we get x plus 6, x plus 3. Now with this one, it's still a positive number that I'm multiplying to get. So they're going to add together to give negative 4. So this time it must be two negatives. Still the same numbers, multiplied together to give 3, add together to give 4. I can still just say 4, but I just got to remember the numbers are negatives. Well, that's an easy one, because 3 being a prime number, it's only got two factors, 3 and 1. So it must be minus 3, minus 1. Oh, this sometimes throws people. It's got x's and y's, and I've got to factorise it. What's going on there? Well, I still use the same idea. What multiplies together to give 4y squared adds together to give negative 5y. The reality is I don't even need to worry about the y, because it will look after itself. It's the number that's important here. Multiplies together to give 4, adds to give negative 5. So it's got to be two negatives. So it's negative 4 and negative 5. But when I write it down, I don't write negative 4 and negative 1. I write negative 4y and negative 1y. Now, so the y's will now look after itself to get the y squareds. Now, that's great. Every one of those are what we call monic, where the coefficient of the x squared was 1. What happens when they're not? There's lots of different ways of doing this that I've seen. I like this idea of splitting the middle, because it keeps the idea of what multiplies together to give a number, what adds together to give a number. So it's still that same sort of idea. But we just got to do something very clever. Instead of saying what multiplies together to give negative 7 adds together to give 4, we say what multiplies together to give negative 21. So basically you multiply the constant by the coefficient of the x squared. In this case, negative 7 times 3. And adds together to give 4. So we're still using the same idea. I'm looking for two numbers. Multiply together to give something, add together. In this case, the numbers are going to be, one's going to be positive, one's going to be negative, because they multiply together to give negative. The positive number has to be the bigger one, because I'm adding them together and it will be positive. There'll be a difference of 4 in the numbers. So multiplies together to give 21, difference of 4, positive 7 and negative 3. And what we do is we split the middle term into those two bits. So instead of writing 4x, I write minus 3x plus 7x. Or the other way around, it doesn't matter. And it becomes a grouping in pair questions now. If I grab the first two, common factor there of 3x, 7 in the other ones, x minus 1 is common, and there's my answer, x minus 1, 3x plus 7. So that's the method that's known as splitting the middle. You may have seen other methods like the cross method. I think is a fairly common one. You may have seen that one as well. But as I say, I like this one because it keeps the same idea of what multiplies together to give, what adds together to give. Let's just try another one. Okay, so what multiplies together not to give negative 12, but negative 24. This time it's going to be a positive and a negative because they multiply together to give negative. The negative number is going to be the bigger one this time because it adds to give negative 5. So we're looking for a number, difference of 5, multiplied together to give 24, 8 and 3. Thank you. So we said the bigger one would be the negative one. So minus 8x plus 3x. Again, we'll group in pairs. Common factor of 2x leaves me with x minus 4. Common factor of 3 leaves me with x minus 4. And there's our factorisation. X minus 4, 2x plus 3. Okay.